Hi, are you confused about sequences and series? Can we visualize them together? This is what the video is all about. It is important to distinguish the differences between sequence and series. For example, if the series summation of absolute value of an converges, then the series summation of an also converge. This is guaranteed by the absolute convergence test for series. However, the same result is not true for sequence. That means if the absolute value of sequence converges, then we cannot guarantee that the sequence an will converge. Getting into details, consider the sequence a sub n equal to minus 1 power n plus 1 over n, and the corresponding series summation of en, which is summation of minus 1 power n plus 1 over n. Let's examine them term by terms. For the sequence a sub n equal to minus 1 power n plus 1 over n, for the first term, an is equal to 1. And then for the sequence of partial sum, s1 is sum of an, which is 1. For the second term, n equal to 2, a2 is minus half. But then, for the sequence of partial sum of the first two terms will be 1 minus half. For n equal to 3, the sequence becomes 1 over 3. And then the sequence of partial sum becomes 1 minus half plus 1/3. We can continue to find what happened when n equal to 4. a4 is minus 1/4. s4 is 1 minus half plus 1/3 minus 1/4 for the sequence of partial sum. And then n equal to 5. The fifth term, a5, is 1 over 5. And the partial sum of the first 5 term is 1 minus half plus 1/3 minus 1/4 plus 1 over 5. And we can continue this forever. In short, the sequence general term an is minus 1 power n plus 1 over n, and we know this sequence is a null sequence and converges to 0. And the sequence of partial sum, s sub n, is sum of ak for k equal to 1 to n, which is equal to sum of minus 1 power k plus 1 over k for k equal to 1 to n. And what does it converge to? Now let's watch an animation showing you the an and sn together in a sequence and series diagram. This animation will show you the sequence and the series in the same diagram. The sequence is minus 1 power n plus 1 over n, and the sequence of partial sum, s sub n, summing up the sequence ak, k from 1 to n. The blue dot here is showing you the term of a sequence, and the red cross showing you the partial sum. Let's watch the animation. Now, this n equal to 3, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we can see that the sequence, which is represented by the blue dot, is converging towards 0, and the partial sum, which is represented by the red cross, is converging to a number between 0.5 and 1. Let's watch this sequence in more detail. So I want to see if when n becomes large. It is important to know how to use software to help you to explore and investigate mathematics. For example, you can use Excel or you can use Mathcad to explore series and sequence. Here is a graph generated by Mathcad. I have plotted the sequence an and the partial sum Sn for the first 200 terms. So the blue dot here are the sequence an from n equal to 1 to 200. And the red cross are the sequence of partial sums S1 all the way to S200. From here, we will find that as sequence an converts to 0, and the sequence of partial sum Sn converts to somewhere close to 0.7. Therefore, you can say that summation of minus 1 power n plus 1 over n, when n goes from 1 to infinity, is about 0.7. That means 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1 over 6 plus 1 over 7 minus 1 over 8 and so on. This is about 0.7. But do you know what is the exact value? Well, it is worth knowing that you can use Maclaurin series of ln 1 plus x and the Abel's limit theorem, which you can find in David Brennan's text, page 35, that this exact value is ln 2, which is approximately 0.6931. I wonder, is there any software that can get this exact value? I hope this will clarify any confusion you have with sequence and series.